Hi, this is Synthchaser from Synthchaser.com. We're continuing the repair of this ARP Avatar guitar synthesizer. In the previous video, we took a tour of the architecture of the Avatar, tore down the synthesizer, and replaced capacitors. I've done a crude cleaning of the sliders and the switches, and I've set up boards A, B, and C on my bench so we can test and repair the synth engine separate from the guitar interface. Once we know the synth section itself is working, we'll reinstall it into the case and see if we can get the guitar interface working with it. So the synth section actually appears to be in pretty decent shape. I've not done any kind of calibration, and the oscillators are working, and they're actually scaling fairly well with each other. Most of the functionality is working as intended. I did notice a couple of issues. First of all, on VCO1 is working sawtooth and square wave, but VCO2, sawtooth is working, but square wave is not. Another thing that I noticed was the LFO modulation of the filter. So let's go back to this. We'll lower the cutoff frequency a little bit. We have, let's see here. We have sample and hold modulation of the filter here. But if we switch to LFO sine wave modulation, we're not getting the modulation effect. This one is the LFO sine wave modulation of VCO2. And that is working. So we do have the LFO spitting out a sine wave. So my instinct was that these slide switches were still dirty or they're defective, but it actually didn't turn out to be the case. In the Avatar, like the Odyssey, there's this interconnect board here that sits across and connects boards A, B, and C. So this board is bringing the VCOs and the LFO from board B, here where it's generated, over here to board C, where our problem is evident. On the top side of the board, between these sliders, we can actually probe the header pins that the interconnect plugs onto. So on board B, here at pin 5, 1, 2, 3, 4, 5, we can actually see on the scope the VCO2 square wave. So we know that that signal is good. And on pin 2 here, we can see the LFO sine wave. So these are both getting generated and are present on the output of board B. But if we move over to board C and check the corresponding pins, so let's see, pin 10, so 2, 4, 6, 8, 10, 7, 8, 9, 10, yeah. So 10, we're missing our VCO2 square wave, and on pin 8 we're also missing our LFO sine wave. So let's actually power this off, and with the multimeter we'll measure continuity between these pins on board B and board C. So if there's continuity, we should hear a beep when we probe the pin. So let's check the VCO2 square wave. So that was pin 5 on board B and pin 10 on board C, and there's no continuity there. So there's some kind of connection problem, and since the connector in common is either this one or this one, I would expect that the problem is going to be one of these two connectors, the Molex connectors on the interconnect board. So I'm going to take this apart and investigate. I'm actually guessing it's going to be this one, because as I wiggled the board around, it kind of, the LFO one kind of came back to life. If I wiggle the board, so I've got this firmly seated now, and it's not modulating it. So if I wiggle it around some more, maybe I can get it back. probably going to be this connector under here. So I checked the solder joints on the back of the interconnect and of the header pins on the board, and they actually looked okay. And then looking down into the Molex connector itself, usually you can see if like a contact has been like crunched down and is not going to make as good contact, but it actually looks okay. And but for whatever reason it's not making good contact, so basically we're going to need to replace this Molex connector here. And I don't think I have one of these in stock right now, so what I'm going to do, just to keep things moving along, is I'm going to take the interconnect board from another Avatar and kind of tag this one to be replaced on my next parts order. And yeah, indeed, that connector on the interconnect board was responsible for both the VCO2 and the LFO sine wave modulation of the filter. So now I can turn it on, and I've got the filter modulation going, and I've got VCO2's square wave going. So that took care of that. So now I'm going to give this, I'm going to run through everything again because I changed the interconnect board. I want to make sure that there's no other problems with this new interconnect board. And so I'll retest everything in the synth section. I'm going to calibrate it, and then I'm going to put it back in the case and connect boards D and E for the guitar interface. Before I put the boards back, I'm going to clean up the case, and then also the side panel came off, and you can see on this double-sided tape it was all dirty there, so it's obviously come off before, and this thing is probably just barely clinging on. So I'm going to have to reattach this side panel. So I've got the Avatar back together, and I've hooked it up to a vintage ARP Odyssey that's using CV gate and trigger. Previously on the bench, when I had the key step controller there, I was just using CV and gate. Without a trigger signal, you're not able to test the ADSR, so I wanted to be sure to test that out thoroughly. And we can see, we raise this up, there's our attack. We can modulate the oscillator by the ADSR. And we hear that pitch going up during the attack portion, so the ADSR is okay. So now that we have the synthesizer section working, put back together, tested with CV gate and trigger, now it's time to hook up a guitar and test the guitar interface. So I'm not willing to mount the pickup on a guitar, but I would like to test this. So normally the pickup sits under the strings, and the vibrating strings above the pickup are detected by the synthesizer. So what I'm going to do is actually I'm just going to hold the pickup above the strings like such, and pluck the strings and see if we get both the string gate signal here. So we want the guitar interface to have detected that I've plucked the string, each of the strings, and then we want to hear something coming out of the synthesizer. So let's start over here. No. Yes, you see the A LED flashing. D is working. G is not working. B is not working. And E is not working. So we got A, D, oh, there's G. Maybe I'm just not holding it right over it. Okay, so there's G. And let's try B again because I saw it flicker. Now I'm hitting G by accident. There's B. Problem is this pickup kind of is arched, so I gotta kind of rotate it as I go. So we have B, G, D, A, but not E, but not either E. And we're not hearing anything come out of the synthesizer. We can hear the guitar. If I turn the guitar up in the mix, let's see. There's that E. Well, now E is gaining. So let's turn it down in the mix. It's gaining now. All right. Go figure. Okay. And let's try the little E. Make sure I'm over the right. There we go. You can hear it when you, yeah. Okay, so all of the pickups are working, and all of the gate detector, the string detector circuits are working. Let's go over here to the hex fuzz and hear what that sounds like. Cool. And non-fuzz. Okay. Anyway, so we are able to detect the string triggers, but we're not hearing anything from the synthesizer. So let's see what that could be. First of all, let's do this. We have it on the ADSR mode now. Let's just turn up the open the VCA. So I hear clicks. So like almost like there's no control voltage for the synthesizer. Let's try getting a string here. Yeah, nothing. So from what I'm hearing, it sounds like there's no control voltage coming to the synthesizer section, while it is detecting the string triggers. So what I'm doing is I'm measuring the control voltage here at the interconnect on so coming off of board A going to the oscillators, and I said we have no control voltage, so like 0 volts. Well, we actually have negative 10 volts there, and when I trigger a note with the guitar interface, I want to make sure I get one. Yeah, light LEDs are flickering on the panel, and there's no change to the control voltage coming out here of the synthesizer. And we know that board A handles control voltages correctly because we just tested it via the CV gate and trigger jacks on the back of the synthesizer. So that's routed up to board A and then into the interconnect and to the oscillators. So our problem is going to be that the control voltage coming from the guitar interface boards D and E is very, very wrong. So this is where our CV gets generated. And this is the module D prime on board D, and coming out on pin 7 we can see that negative 10 volt control voltage. So this is where the negative 10 volts coming from. Whether or not this thing's getting correct inputs or stuff like that remains to be seen, so we can't just assume that this module is broken. So according to the service manual, there should be a train of 4 volt peak-to-peak pulses coming in on this last pin of this module. So I've got the scope connected there, and we'll pluck some strings and look on the scope to see if we're getting that train of pulses coming in. So looking at that without plucking any strings, I do see a train of approximately 4 volt peak-to-peak pulses going through there. So I'm going to hit some strings with the pickup in place and see if if anything changes. Yep, there, you see the pitch changed. Not the pitch, but the frequency of those pulse waves. Is changing, and they're within the audio region, so we should expect to get some control voltage coming out of that module. So there is a pin on-off on this D prime module, and I checked and it's 15 volts. Whether that's on or off, I'm not quite sure. I'll have to take a look at how this pin is being set in the schematic. And it appears that on-off pin is not being set. So here's the circuit board layout. Here's pin 1, 2, 3, 4 is skipped, 5, 6. So this is the on-off pin. You can see that it's not connected to anything. This is 7, which is the CV out pin, but 6 is not connected to anything, so that on-off doesn't affect anything. And if you look at what this module takes as input, there's the pulse input, which we verified, the on-off, which doesn't do anything. It spits a CV out that's trimmable and has another trimmer for zeroing it out, and then it takes the power rails as input. So at this point, I think we can conclude that this module is the culprit. And while the good news is it's not epoxy potted like this guy, the bad news is there's still no schematics published for this one. So we'll pop this out and have a look at it, see if we can figure it out. So while I don't have schematics for this, I did pull a D prime module from another Avatar just so I can see what the chips are. And look at the board while I'm probing it, because it's mounted upside down. And what I'm going to do is I'm going to look for each of these chips. I'm going to look at the inputs and the outputs and see if for any of the chips, if any of the outputs don't mesh with the inputs that they're being provided. I'm probing around these CMOS chips, these 4000 series CMOS chips. There's a Z3, this one on top, which is a 4013, a flip-flop. And then there's Z2, which is a NAND gate. And if I probe one of these pins, a particular pin, it actually generates output on the synthesizer. So generally what this means is that there's a problem with the chip, essentially, that basically the high impedance path between my scope probe and the ground is enough to affect the output of the chip. So this particular pin, it's connected here on Z2 pin 8, and that is a input to a NAND gate. And that is coming from over here. This looks like pin 15 of Z3. And if I touch it there, it does the same thing. And pin 15 of Z3 is, sorry, not pin 15, 13. Pin 13 of Z3 is the output of the flip-flop. So it's likely that one of these two chips, Z2 or Z3, are bad. So what we can do is we can just take them out and test them in the chip tester. While I'm desoldering this, I thought to mention that just the fact that while probing it affected the output, that doesn't necessarily mean there's a problem in all circuits. Things like oscillator cores, VCAs, things like that. You are going to. It is normal operation if you hit it with your scope. You're going to affect the output. But for this particular situation, we're talking the output of a CMOS chip, a non-open collector CMOS chip, going into the input of a another CMOS chip. That's what struck me as abnormal. So the first chip I took out was the 4013. That's the one that had the output was on pin 13 of that. So we're going to test it here in the IC tester, and it fails. So it's going to tell me what pins are not testing normal. So pin 1, pin 2, pin 12, and pin 13. So that's the pin that I was probing that was given the pitch change. So we'll start off then just by replacing this chip and then see if we need to move on to that 4011 or if this does the trick. Okay, I replaced that 4013. Turn it on. And let's see if we have any difference when we strike a string. So we do have we're getting a CV now from the strings. I had the VCA open, so that's why we were hearing it even when I wasn't striking a string. So now let's try turning. So I turned the VCA. I closed the VCA and I'm turning on the ADSR, and we'll see if when I pluck a string we get some output. Yes. And I stop the string and it goes away. Let's try a different string. I'll stop the string. Try it again. Gotta get the pickup position. There we go. So this looks promising. So I'm not sure how I was holding the pickup before, but this is the way that I want to hold it for testing. So like for this E string here, I'm going to test that not only does it get triggered when I play the note, but if I increase the pitch of the string, it affects the pitch of the CV that we're getting. There are some trimmers for the guitar interface on the front panel, accessible through little holes. There's string sensitivity, so you can adjust the sensitivity for each of the strings individually, and that's going to be important as they may be sitting from different distances from your pickup when you mount the pickup on the guitar. So you can fine-tune that in so they all trigger reliably. There's like a master trigger sensitivity a trimmer. There's a trimmer to adjust, like basically when you want to, as the string dies out, when you want to cut it off from affecting the pitch. Over here on this board D, there's two trimmers here. One sets the initial frequency or the initial voltage of your volts per octave converter, and the other scales it, so you can scale it for your, between your two E strings on your guitar. And I'm actually not going to mess with any of that. I'm not, because the ARP Avatar's design kind of sucked. Just being honest here. It kind of was a lousy product and kind of contributed to the company going out of business. I'm not going to, when I sell this, I'm not going to warrant that the guitar interface is working perfectly, that it's scaling and in tune and all that stuff. Just real basic functionality that, you can trigger each, trigger the synthesizer through each of the strings with the pickup, that the pitch changes. So because it is what it is, I'm not going to mess with it further beyond that basic functionality, and I'm not going to represent that it's working the way ARP intended it to, because honestly, ARP never got it working the way they intended to get it working. So why, if they didn't get the job done in the 70s, why is it my responsibility to get it done for them now in the 2020s? And there we have it, the conclusion of the ARP Avatar repair. So in this video, we saw that the synthesizer was working when controlled via an external CV gate and trigger signal. And then with the synthesizer section working, we went and tested the guitar interface through the pickup, found that the D' submodule, for which no schematics are published, was defective. And we used some basic troubleshooting skills to repair it, even though we didn't have the schematic. And now it appears that the Avatar, and with its guitar interface, is working as reasonably well as one can expect an Avatar to work. So I hope you found this to be an interesting look at the ARP Avatar. I'm Synthchaser from synthchaser.com. Thanks for watching and have a great day.